So it's a real pleasure to be graduating a number of students. Number two in a row here is Melissa Stefun. She worked as an undergraduate here. She got a degree from our department. I think it was our department, right? Yeah, and worked in my lab for a while. And took a few years off to work for the EPA, as environmental students sometimes do, and then came back to further her credentials and has been working on enhanced cover crops and especially the nitrogen aspects in some experiments here. And yeah, she's going to tell you all about her adventures with nitrogen and cover crops and soil health and how improving this management can help in climate mitigation. So, Stefan, it's all yours.
Thanks for that introduction, and thanks everyone for coming. I'm going to be presenting my master's research on managing cover crops for better nitrogen efficiency and soil health. Okay, there we go. That's the sound of active cover crop management. So these are my 3 thesis chapters. First, I'm going to talk about nitrogen leaching. And then second, I'll speak about the spring cover crop management and soil health indicators that I measured. And lastly, I'll talk about fertilizing cover crops. This is a field study, or the design is in the field. And this is the study design that's used for the first 2 chapters I'm going to be talking about. It's a randomized complete block design with split plots. And at 2 fields, this is deployed at 2 fields with contrasting soil textures. One is a coarse sandy loam and the other is a fine silty clay loam. This is a pretty dense plot diagram, so I'm going to break it down more. We have 2 cash crops in yearly rotation, soybean and corn. And we also have 3 treatment levels applied to each crop. So the soybean has 3 spring termination dates for our cover crops, and the corn has 3 nitrate or nitrogen side dress treatments at 3 different rates. So right now this is corn and right now this is soybean, but the next year those would flip, and they would also flip with their 3 treatment rates too. So something that doesn't rotate, that stays the way it is the 3 cover crop treatments. We have a rye single by itself, cereal rye cover crop. That's a pretty common cover crop, pretty simple to deploy. And we have a more diverse mix of 3 species. We've got forage radish, crimson clover, and rye. So some of the idea behind choosing these species is the radish grows really quickly in the fall and it does well at sequestering nitrogen. The rye also supports in sequestering nitrogen too. But since the radish winter kills whenever it gets cold enough, the rye is really there to keep on and be a winter hardy species. And the crimson clover adds nitrogen and it also pumps up the biomass really nicely. So, and the last cover crop treatment is a no cover crop control. So the only vegetation there is weeds. But I will note that these fields or this location has had cover crops for quite some time. So our treatment of no cover is kind of more explaining what happens when you take cover crops away, when they've been there for a while. So I'm not going to talk a lot about our cash crop yields, but I do want to point out that even with these different practices we're trying out, we have pretty respectable yields. So this is the average yield over 3 years in the state of Maryland for corn. And then these are our average yields. These are hand harvest, by the way, because these plots are so small, it's kind of hard to use a combine and reliably get data on the different treatments. But in all the cover crops, we didn't really see any yield penalty, which is something sometimes people say you're going to have. And the same for the soybean down here in the green. So we didn't see a yield penalty, even though we're using some different practices that sometimes people say you'll experience that. This is my plot diagram, or my field timeline that shows when different crops are in the field, when cover crops are in the field. got the different months. They're probably pretty small, but you might be able to see them. And this is for 2021, 22, and 23. So we collect the cover crops or sample them in the fall and then again in the spring. And we'll have 3 collections for the spring because we have the 3 different termination times. So and that's just in the soybean here, and then it'll change location and rotate. Our cover crop plantings, we do have to plant slightly different times for corn and soybean because the soybean has so much leaves covering the soil, so it's not really light enough for cover crops to do well, so that comes out a little later. We use lysimeters to measure the nitrate and other nitrogen forms in the leachate water from October to April. And one thing you notice when you kind of step back and look at this is that the cover crop is actually in the field quite a bit longer than the main cash crops. So they have a really big effect on the system. If you don't have cover crops, you're actually bare for a lot of the year. We have them overlapping so that we can get the cover crops growing during some nice warm season time so that they can build up enough biomass later on. There we go. So my first chapter, nitrogen leaching, my objective was to determine the effect of the previous crop, soil texture, and cover crop treatment on the nitrogen concentrations and the forms of those in the micropore water below the rooting zone. You can't quite see it here, it's poking out of the cover crop, but there's a lysimeter there. So methods I used were suction lysimeters. Here's a picture of them in the different treatments in the fall. If you're not familiar with a suction lysimeter, it's basically a tube that has a cork on the top and some different plastic lines with clips on them. And it's hollow and it goes all the way down. Mine went down to 90 centimeters. So they're collecting leachate from around 90 centimeters right there. And this is a porous tip. It's ceramic, and so it can actually exchange water through here. So what we do is we pump some of the air out of this tube, and the negative pressure will pull in soil water nearby over a certain amount of time. So you're able to collect that soil water. So the study, as I mentioned, they're in the field from like October to April, and I studied it during 2 leaching seasons, 2021, 2022 through 2022 and 2023. So I sampled the leachate biweekly during the fall, the winter, and the spring. I measured the electrical conductivity, which gives us some idea of the ions dissolved in the water and the pH. And then I suction filtered it. Oops, I didn't realize the wheel would do that. Cool. We suction filtered it through a really fine filter to get rid of any particles or anything like that. So yeah, that's micrometers, so that's pretty fine. And then we acidify them for storage. These are the chemical methods that I use to look at the different nitrogen forms: nitrate, nitrogen, ammonium, nitrogen, and total nitrogen. And I'm going to talk a little bit about dissolved organic nitrogen. I didn't measure that directly, but what I did is I took the total nitrogen and subtracted out the mineral forms that I measured to get dissolved organic nitrogen. So methods for biomass collection are that we take the above ground biomass and the radish roots as well in the fall when the radish is around. And we take the area we take is a 1/4 meter quadrat that we take on either ends of the plot or the subplot that we measure from. We'll separate them by species, dry them, weigh them to assess the dry matter, and then grind the biomass up so that it can be analyzed for the chemical tissue composition using the LECO. As with a lot of things, studying leaching and cover crop biomass is somewhat dependent on the weather. So I here have some weather data from October to the end of April from the PRISM Climate Group from Oregon State University. There's a lot of data on here, but in the darker orange, I have the precipitation, so you can see those little precipitation events. And then the lighter orange is the cumulative precipitation, so you can see how it's been building up over this time. And this purple dotted line is the 30-year average or 30-year normal for that cumulative precipitation. And then in the blue, I have the mean daily temperature and the 30-year normal for that. So initially, you can see how this flat line here shows that we're not really increasing a whole lot of our moisture here during the fall. We have a few rain events and we get it up to the average, and then we also don't have a lot of rain here. So this is showing you that's a dry, kind of a dry time there. Got a little bit more, but doesn't ever quite catch up to what the precipitation normal would be. And I will note that I split up my lysimeter data and my leaching data into seasons of biological significance. I'm calling them fall, winter, and spring original. The fall is maybe not what you think of as fall, but it's from when I start taking measurements in October until it gets cold enough that the winter hardy species are dormant and the non-winter hardy species are getting killed by the winter. And we're not going to be seeing a whole lot more transevaporation, evapotranspiration going on. So, and then the winter will be after that. That's going to be stopping, or I'll cut it off a little early. Most people wouldn't think spring starts in February, but if we have a number of days, maybe 5 consecutive days where the high temperature is 55 degrees Fahrenheit or 13 degrees centigrade or higher, the plants start to come out of dormancy, and so they're starting to have some impact on the system around. So that's why I split it up that way. So this is my nitrate results for the first leaching period that I studied. I'll point out I had to use a non-parametric test because this data was so, I couldn't transform it to any shape of normality at all. So I used non-parametric tests. Down here I have the 3 cover crop treatments, the rye, the 3-way, and the no cover. And then each color is the texture of the different fields that I was at. So sand is that peachy color, and then silt is the blue. And then I have that data broken up for the fall, the winter, and the spring, and this is kind of the approximate time when that actually is. And this on here is the nitrate nitrogen scale in milligrams per liter. So just the initial look at this data, we see that it's pretty low nitrate is leaving the field in general. These are super low, and our detection limit is not much below this anyway, so this is very, very low, especially in the fall. And since the nitrate is so soluble, this is probably, at least at this point, that there's not a whole lot of water going through the profile. So even in the no cover, we're not seeing a whole lot leaving the field. And we never actually see a ton leaving the field, but just to compare it to itself during different seasons. So these aren't like remarkably high levels even for the no cover. So fall, very low, it's dry, not a lot of water to carry it. In winter, the no cover, you start to see leaching starts to happen, but the cover crops are keeping it low while the no cover is losing to somewhat different degrees depending on the soil texture that is at the field. And then in spring, normally in spring, we see that all the nitrate that could be lost is already lost by a wet fall and a wet winter, but with only a wet winter or sort of wet winter and spring, a lot of it was actually left to leave the field in spring. So no cover continued to be higher than the cover crops. So the biomass for this fall was not bad. I'm showing this in kilograms of nitrogen captured. So this is going to be the rye at the sandy field, the 3-away at the sandy field, the no cover at the sandy field, and then the same for the silty field here. And I have the different cover crop species broken up into these different colors. So we assessed this in late November. These were planted September 1st of that year. And you can see that the 3-way is definitely doing the best as far as capturing nitrogen during this time. And that's largely because of the clover is providing good biomass, and of course the radish is doing well. So we've got the radish fruit and the radish leaves up here. So if we had a pretty dry year or dry season from October to April during this year, we had a pretty different story or different setting for the next year. So this is the same data just for the October 2022 to April 2023 year. We've got plenty enough rain to cause some leaching here if there's leaching that can be had. And we did see that these are going to be higher levels, still nothing really crazy high compared to what you might see coming off of other agricultural fields, but high compared to last year at this site. So first thing to point out, the top tick mark on the previous graph that I showed you was 10, and this one is 3. So this is 3 times more. I just wanted it so you could see it well, but this is higher. So we have the cover crop treatments, fall, winter, and spring, and the different textures. So in fall, leaching has already started, like we might expect when we have enough precipitation. And the rye is really doing the best at keeping it lower. It's keeping it pretty down there, but none of these are really crazy high either. And as with the previous year, when we move on to winter, it does increase at both places. And by this time, the rye and the three-way are pretty much equally good at keeping the nitrate from entering the water. And in spring, we've already lost pretty much everything we can lose, not completely, but it's pretty low here and not a whole lot different, even though it was statistically different from the cover crops. So we also had somewhat of a different fall for temperature. It was a little cool, which is kind of surprising, and we only had maybe like a little bit where it got real hot and then it got cold again. And so this temperature kind of didn't really help us out when it came to nitrate or nitrogen capture from the cover crops. So you can just initially see this is less than it was the previous year. These cover crops were planted about maybe a week later, so I do think that had an impact. So maybe around like September 7th or a little bit later than that. With the rain, it's kind of hard to get into the field all the time without just causing issues. So I think that was a little bit of the logistics problem. But also I think those cooler temperatures did impact their ability to grow well. So they were just growing a lot slower. So three-way mix N uptake was still pretty high compared to the other two. But the rye isn't doing too badly either. But it's not nearly as high as it was the previous year, and you can see that the radish really didn't like what happened that year. So we didn't have a whole lot of that going on. All right, so a little bit about the forms of nitrogen in the soil water. Typically, you would only look at nitrate because that's thought to take up the largest amount of the nitrogen that's dissolved, but for us, it really wasn't the case. Here we've got the different cover crop treatments, rye, three-way, no cover at the sandy field, and at the silty field we have the same, and then I repeat that fall, winter, and spring, and this is the fall of 21 through the spring of 22, and then the next year here down at the bottom. And then the nitrogen milligram per liter on this side. So I've been talking about nitrate for a while now, and that's just the green down here. So it's definitely pretty small compared to the dissolved organic nitrogen. This is kind of a surprise because it's just not usually thought to be a huge portion of the leachate. But for us, it really was. So generally, the organic is more than half, or at least half, or at least it makes up the largest portion of what's dissolved in there. So that kind of lets us know that it's important to track dissolved organic nitrogen in our leachate. And as we saw with the nitrate data, the total nitrogen is higher this year as opposed to this more dry year. So that was similar in that pattern. So moving on to my next chapter, cover crop management and soil health. My my objective was to measure the effects of the maximum spring cover crop biomass acquisition and the growth period length on the soil characteristics after 3 years of these treatments. So the soil health is kind of a vague term, so I'll just define it as the capacity of the soil to function and provide ecosystem services, and including water management and carbon sequestration. So the things I measured were the permanganate oxidizable carbon, the total carbon, and macro aggregation, or how much of it is aggregated, and the bulk density. So in biomass in the spring, we collected 2 springs worth of biomass, 2022, 2023. The above ground biomass was collected only since the radish is no longer with us by this time. And we collected at 3 different times. So the early terminated plots were in mid-April. This isn't really early termination for most cover crop fields, but that's what we called it because it was our earliest. But a lot of cover crops are typically terminated earlier than this. And then the middle terminated would have been May 1st, which is today. So that's probably why Cassie is out there in the field collecting cover crops. So the work goes on. And the late terminated is mid-May. So that middle terminated is where we plant green. We plant the cash crops at that time as well, and terminate the cover crop later while the cash crop is still growing in the field. And the soils we collected, we only collected them one time to assess the impact of these 3 years in June of 2023. And this is about how much soil we get. This is 7 centimeters. This was just for a picture, so this isn't one of the samples, so don't worry, I didn't roll it around and then put it back. So we took a stainless steel cylinder and drove it into the soil, making sure it stopped at that point, and then would cut off that, so we have like a specific volume of soil that we collected. And we took 4 samples per subplot, making sure it was in an untrafficked row that wasn't impacted by the farm equipment. We sampled the early and the late cover crop termination plots and the 0 and high nitrogen rate plots. These are the methods I used to study the soil health metrics. And there's me doing some sieving and weighing. So first, here's the biomass for the spring. I've got the early, mid, and late termination times. As a reminder, this is the mid-April is the early, mid is May 1st, and the late is mid-May about. And I've got the 3 types of plants you're going to see here. In the clover is red, rye is green, and the weeds are blue. And they're in their amounts over here. So we've got 3-way rye, no cover in each time point. And this is dry matter in kilograms per hectare. So if we're just looking at the early kill, you'll see that the 3-way is really smoking the other 2 when it comes to biomass. So this is due to that clover bushing out really quickly and early, and it gets pretty big biomass-wise early in the spring. But we actually don't see it change over this month, and that's largely because it's focusing on flowering. It gets really nice and pretty, so it's kind of fun to see it flowering, but yeah, it's not really increasing biomass, but it is establishing a nice high biomass right here, even in mid-April. But rye is a different story. Rye actually is pretty small here in the early, so if you terminated it then, and it was all you had was rye, you'd have a pretty small amount of biomass on the field. That isn't really going to provide you nearly as much mulch later on, and it's not really pulling in as much carbon into its tissues and transferring some of that into the soil. So that's something that, I would point out, that a lot of times cover crops will look even smaller than this because a lot of folks will actually terminate even earlier. So when we move from early, the rye doubles in its biomass, whether it's in a mix or it's by itself. And then when we get further to the late terminated, it doubles again or almost doubles again. So over this time, it's quadrupling in biomass. And both cover crops suppress weeds at each time point. So they're doing equally well at keeping weeds from becoming an issue. This is a little picture of what planting green looks like. Looks like it's like going through all this biomass and planting the cash crop into all of this living cover crop. So that would be our mid termination, which is already kind of unusual. Not a lot of fields you're going to see them being planted green. So we are moving on to soil health indicators results. They were affected by the cover crop type, but they weren't very affected at all by the cover crop termination date. That is something that maybe we'll look at in the future to see, but the 3 years were not really long enough time to see an impact of the termination date. And it's also true that as with the crop rotation, we rotated the treatments, which one of them was the termination time treatment. So all these plots didn't experience that for a full 3 years at all. So I'll talk about the soil carbon. Got the epoxy by cover crop and field soil texture, and then the carbon percent by cover crop. And the 3 ways in the blue, and the no covers in the orange, the rise in the green. And I've got it at the sandy field and the silty field. And so if you're not familiar with epoxy, it's where we take this potassium permanganate, mix it with soil in a solution, and reducers in the soil reduces the potassium permanganate from this purple color, and it gets lighter and more colorless over time. So we're really measuring kind of the soil reducing power. It's not a raw measurement of the actual carbon in the soil, but it is related because a lot of those reduces are carbon. So is exciting to see a cover crop effect here. The no cover is lower, and we only see this at the sandy field. There, you can see there's a difference at the silty field, but it's not significant. But the 3-way and the rye are both increasing the soil reducing power after only just 3 years. Or put another way, the no cover lost that over only 3 years of not being cover cropped. And the carbon percent shows a similar pattern, although it's less marked even at the sandy field, and the 3-way is doing better than the rye at adding carbon to the soil. And this was somewhat expected because in the literature, the epoxy is usually more of an indicator, an early indicator of things that are going on in the soil, and the carbon percent will lag behind that indicator. So the epoxy will show it before you would actually see it in the carbon percent. So I wouldn't be surprised if after more years, we actually do see that the rye is able to also differentiate itself from the no cover. But in the amount of time we had, that's what we found. And in the soil structure, we also saw some differences, which was cool to see. So this is the percent of the macro aggregation from the 0 to 7 centimeters of soil that we measured, and by cover crops. And this is also just at the sandy loam. We didn't really see an impact at the silty field, or not one that was statistically significant. So this is the amount of soil that's in aggregates that are more than 1 millimeter wide by weight of dry soil. So the 3-way is actually increasing aggregation, and the no cover has lost some. And when we go look at the bulk density, this is the density or the weight of the soil per volume. The 3-way is actually making this soil less dense and more porous. It has more pore spaces. So this can help us by allowing water to percolate through the soil more quickly, enter it more quickly, and you're less likely to have runoff and flooding and just erosion that would put sediment into water. So this is a benefit definitely for water quality. So we think maybe that the cover crops like the radish and the clover were definitely making an impact in just putting tap roots into the ground with the radish, and then the clover was adding some nitrogen, so maybe it was just kind of stimulating the biological community there. So my last chapter, fertilizing cover crops for increased efficiency. My objective was to determine if small fall nitrogen applications can increase the nitrogen captured by more than we applied, and if so, to develop a soil nitrate test to find out where we would want to do this. And this was mostly because we've seen farmers reach out to us who are farming on sandy soils. They'll plant a cover crop and it doesn't do a whole lot, like it looks small. This is a radish, by the way, not that you could tell. This is what a radish looks like when it has enough nitrogen to grow. And something that occurred to us was that since research in our lab found that there is actually a substantial pool of nitrogen just down 1 meter into the soil, the topsoil is pretty depleted of nitrogen. So what if we gave it a little nitrogen and saw if it can get down there fast enough to intercept that, and then it wouldn't look like that. So that was the theory, but it didn't actually bear out in our study, but I'll get into that. So this was a field experiment 2020, 2021, and 2022. And it's a different design than the two chapters that I just looked at with you. So we looked at 12 site years using early planted cover crops, overseeded into corn, and we restricted it mostly to sandy coastal plain soils. So in 2020, we applied the nitrogen with farm scale equipment, that's heavy equipment that you can't bring in until the corn's already been harvested. So we applied the nitrogen later on. So that's in October, and we applied urea, ammonium, nitrogen at 3 different rates. And we thought, after seeing there wasn't a whole lot of response, maybe this isn't enough time, maybe there's not enough warm weather growing degree days for the cover crop to make use of this fertilizer. So the next 2 years, we switched to a different design where we took these paired mini plots, and we gave one cover crop plot fertilizer and another without fertilizer. And we were able to hand apply that, just kind of spraying it. So we could go in September before the corn was harvested. So this also allowed us to really increase our replication and include some sites on working farms too. So we did 1 rate of nitrogen the first year, and then the next year we doubled it. So this is what those little mini plots, they're really mini. So these flags would stay in. So we would have nitrogen applied to one and the equal amount of deionized water to the other. And you can't quite see it super well, but we used software to do green ground cover percentage analysis so that we would only include or pair up cover crops if they differed by no more than 5% in green cover, so that we were really comparing similar amounts of biomass and how it would respond to the nitrogen. So we took soil samples right before we fertilized till 30 centimeters at each pair and 6 places around it, and did mineral N analysis so we can get an idea of what was already there. And we came back in December and collected the biomass as well as the radish roots and measured the total nitrogen via the combustion LECO. So as I mentioned before, 2020, we didn't see much biomass response. We didn't see anything with the mix, nothing significant. And with the rye, we saw a trend, but it was pretty small. This is really not a whole lot of dry matter here. And for the highest rate of nitrogen we applied, we think we actually saw some fertilizer burn. So that might be why this is lower. But we also saw that the tissue nitrogen percent wasn't affected by fertilization. So that was a bit of a surprise. So we changed our design, increased replication. We applied the fertilizer earlier. So for 2021 and 2022, also not a whole lot, a little more than in 2020, but not nearly in amounts that would be enough to merit fertilizer. So the mineral nitrogen is down here. That's the initial mineral nitrogen that was in the soil when we fertilized. And then this is the nitrogen uptake response, which is the amount of nitrogen that was taken up by the non-fertilized cover crop subtracted from the one that was fertilized. So how much more did it take up when it got fertilized? And then these lines are here to show you how much it needs to take up more than we applied. And those are in green, the ones that took up more than they applied. And only 13 out of the 96 plot pairs met or exceeded this threshold. So that is really not convincing to say that this actually does anything to increase the nitrogen efficiency of the cover crop. And quite often it wasn't even related to the soil nitrogen. So in 2021, it was related, even though in 2022, we used a wider range of soils that had more nitrogen here and less here, but we didn't see a response or a relationship. So that was not going to allow us to think that was a good treatment for increasing nitrogen efficiency. So my take-home lessons to conclude are that even with not using a ton of nitrogen fertilizer, we got respectable yields compared to the commercial in our state. And we also did that with very little nitrogen leaching. So they had enough nitrogen, they were doing well, but we didn't lose a lot of that. Our enhanced cover crop management further reduced that nitrate leaching down to like nearly undetectable levels. So we're running a fairly low nitrate system, but it's not a low yielding system. Planting into the living cover crops and allowing the cover crops to grow longer fixed 4 times the amount of carbon in the cover crop biomass, some of which is going to go into the soil as it decomposes for more long term. And the enhanced cover crops, especially the multi-species cover crops, improve the soil properties for water management and carbon storage. And that's after just 3 years. And applying a nitrogen boost to the cover crops is not something we recommend based on our data. So I will thank you all for listening, and I thank you to all my financial supporters and everyone in the lab that supported me, and shout out to this frog for being my favorite, or almost my favorite wildlife encounter while I'm in the field. If anyone knows what kind of frog this is, I'd love to know. And yeah, any questions that you have, I'd be happy to answer. Daniel.
It seemed like the three-way cover crop mix outperformed the rye in several aspects, and I was curious to know if the three-way mix is currently being used by farmers in Maryland, and if yes.
I think some are using it or something like it. I have seen some mixes where maybe it's just a grass and a brassica species. So I think some are using it, but I think it's not as common as just a plain old grass cover crop. That is just a lot slower. So it's definitely recommended, I think, for quite a bit. I wouldn't ever take that grass out because I think it does provide something for just stabilizing it and keeping nitrate leaching low. But yeah, I think more should use it. But it's a little complicated. It's not super easy to deploy all that and mix the seeds. So it's something that would take time. Carson.
I had a question in the same realm is there like an advantage to maybe using the rye that you could maybe sell that or it makes a better mulch or something? I mean, you mentioned that it's not as difficult to use as the three-way cover, but is there like maybe a financial backing for why you wouldn't use it as well? Like rye sells better, no.
Rye, well, we're not really harvesting this to sell it. It is cheap. So when you're buying the seed, it's cheaper than the other ones. But if I showed you the seeding rates that we used, we actually used, even in the mix, we still seed mostly rye because the radish and the crimson clover are pretty competitive to be able to show up in the biomass. So it's not a huge difference in cost, but I think most people, if they're going to apply a cover crop, they're just going to keep it simple.
Sure.
But yeah.
Cool, thanks.
You mentioned that you're surprised that you saw that the dissolved organic nitrogen was the biggest component of your nitrogen leachate. Do you have any thoughts about why you saw that in this system and why maybe others didn't? What's different? Yeah, I have thought a little bit about that because what's nice is that Vivian is also measuring the same component in her groundwater, and she also has the forest groundwater to compare it to. And we also see quite a bit higher organic nitrogen, even though we see quite high in the field, because normally you're going to see a lot of organic nitrogen in forest water. But it may be that we're vegetating these fields so much that it's basically almost like a perennial system, where maybe that's why we're seeing such high amounts of organic nitrogen, where you wouldn't normally see that in typical agricultural field that receives a lot more nitrate fertilizer, has a lot more time where it's not vegetated at all. So I think that's what I would chalk it up to if I had to guess.
So first a comment, everybody, you should have a link to an evaluation show up in your email. Please be sure to fill it out for everyone's benefit. So I'm just this little broader sort of question, Melissa, but I was out last week with the soil judging team in Iowa.
Yeah.
You know, the most productive cornfields, you know, in the country. And I was shocked. I mean, I think our whole group was shocked at how little cover crop we saw out there at all.
Yeah, they don't do
And
cover
they were very
crops.
proud of their yields, and they boasted about all the wetlands they drained in order to, you know, which sort of rubbed me a little the wrong way. But I'm wondering, what sort of, how, do you have any kind of a sense of sort of general farmer attitudes? I know Maryland sort of leads the world in cover crops, but, you know, sort of how the Maryland farmers are sort of feeling about cover crops? I mean, some of this has sort of been pushed on with regulations and incentives. Do you have any kind of a sense of kind of where the Maryland farm community is on this?
In my conversations with them, I feel that most of them are fairly sold on the idea that cover crops are valuable and they provide something. And they also, I think most of them don't feel like their yields are reduced by that. I think that is somewhat impacted by the fact that we give them these financial incentives as well as some cost share to help them do that, which I think is appropriate, given that it does add a lot of complexity to their operation, and you do have to buy the seed, and you have to seed. And a lot of farmers in Maryland actually go further to fly the seed on early on before they harvest their corn, so that they can spread that seed as early as possible. So they actually pay someone with an airplane to throw it around. So just so it can get planted early and get up a nice amount of biomass. So I think that shows that they do value that, because if you drive to Ocean City around like time when it would be cover crop planting, which isn't really beach time, or maybe late beach time, you will actually see these airplanes running around, and that's what probably what they're doing. So I think they're pretty into cover crops, but I haven't gotten a lot of chance to talk to farmers from other states, but the times that I had, it's just something they're not as familiar with. They don't trust it. They're not sure if it's going to work, which is, you know, I'm not surprised by that, because this is their livelihood and they're pretty risk averse, and they already deal with so much risk where they're just kind of at the mercy of the elements and commodity grain prices fluctuating. So I think it just takes time to get them to consider it. And the ones that did do it, a lot of times I think they would say, well, maybe this works in Maryland, but I don't know if it's going to work where I live. It's so different. So there are kind of local cultures too.
How does it work with like the seeds into like that tall vegetation?
The planting grain.
Do they germinate and have light, I mean, what, or how do they grow a cash crop? Does that then grow and outcompete a cover crop?
So we do terminate the cover crop, even though, because we're using these Roundup resistant corn. So we can spray herbicides on the cover crop and it dies, but the crop is not affected at all because it's genetically modified.
Plant it as it grows and then you spray it?
So we did do that in some of our treatments. So sometimes we would plant in and then we kind of crimp down that cover crop. So it's like laying down flat, and some of them get terminated just by that, but most of them are not going to take that lying down without getting sprayed. They're not going to die. So you can crimp and kill a lot of cover crops, but I don't know. We don't really do that because it just doesn't quite really get 100%. And I think we have seen at times some of the cash crops delay a little in germination. But when we follow that down to what the yields look like, that's not visible in the yields by that point. So we don't really see that.
Planting in and then crimping?
Yep.
Just bury the seeds in a bunch of biomass?
Well, I mean, you don't have to do it that much. I mean, yeah, it's able to get through the biomass. I mean, it's amazing how resilient these plants are. So we're doing that. This is a lot of biomass. Like, this is like waist high. And when I would walk into it, it was like, wow, I'm going through the Red Sea.
Any acre germinate under there.
Yeah, I mean, I think it's quite amazing. So,
Back to this picture, I'll try to explain.
which
it.
picture?
You're not the only one that has that question. I mean, most farmers think that this is something that maybe 1/10 of 1% of farmers in the US do. This is sort of, but it is something that enough have been doing that it's really actually better than this traditional way. So this allows the biomass to take about 4 times as much carbon out of the atmosphere because you're letting the cover crop grow instead of killing it a lot earlier to get it good and dead before you plant, because you have to plant your crop on time. So there's basically a pizza slicer that's slicing through all of this, and it works much better for living plants that are standing up with living roots than it does for a bunch of, if you came in, 2-3 weeks after spraying the cover crop, which is the normal thing to do. So this works amazingly well. A week after that picture, the cover crop itself will be dying and dead, and the seedlings will be germinating through that. If it's corn, you want to roll it down because the seeds sort of detect all of that competition, and that sort of sets their yield and
They lose
not
confidence.
very good. But the soybeans don't care. So the soybeans, we just let it standing up, and then, yeah, they just grow up.
It kind of splits them apart a little bit, so it's more likely.
Well, you're cutting through it.
Mm-hmm.
No, the planter itself kind of rolls some down, so it's, remember, that's gonna die. Because either we're gonna roll or crimp it, or we're gonna spray it.
Right.
So it will die, it takes about a week to die. The cover crop will die.
That's
not the
amazing,
crop.
that's cool.
So it is pretty cool, and it's something that we just started a new project on, but, sort of leading farmers are doing this, and it's been very successful.
Oh, nice.
But
I like seed
it looks pretty crazy,
germination.
there's no question. If you go out to Iowa, with all those black fields and bare soil, and you tell a farmer to do this, they may have heard about it in some farm magazine, because it's sort of a thing, but, no, I don't think I'm gonna try that.
Right, they might think it's
So
just
it'll
burying
be a
money in the
while.
ground.
We've gotta
planting green.
demonstrate the benefits, but.
And all the streams are full of nutrients and
Oh,
sediment.
full of nutrients and sediment, and yeah, you've no idea how bad it is in the rest of the world because we're so spoiled in Maryland.
Made me
We really
proud
are.
to be from Maryland.
We really are. You drive around Maryland in the winter and the farmland is green and there's really not much sediment in the streams. That's just not what it's like in the rest of the world.
Yeah, you asked Dr. Weil about planting green. I'll talk about it all day.
That's right, yeah.
He loves
I got a
it.
question.
Dr. Shunamarandi.
Yeah, at the beginning, you had a yield on one of your slides, 11,320 kilograms per hectare.
Mm-hmm.
That was yield for what? I missed that part.
Oh, yeah, so this is corn, and this is corn in a rye cover crop, corn yield in a 3-way, and in a no cover. And this is the average yield for corn in the state of Maryland during that same time period. And then the same for soybean down there.
Those were high yields, that's what it got my attention. I sort of started calculating, it's
200 bushels.
way about.
Yeah, 200 bushels per
100
acre.
bushels really. I mean,
That's the point. These are not poor yielding systems.
Right,
So we have some organic studies and you do all kinds of nice things, but you don't get much crop, frankly. The yields, but these are yields that are sort of better than average.
yeah, we're
it's
not
almost like
embarrassed.
14 metric tons per hectare, that's.
So these are hand harvest though, so like that's gonna be a little higher than you'll get, because the combine always misses stuff, but it's not gonna be that much higher. So this is not too bad.
And those are pretty respectable soybean yields.
So the smallest unit is just 30 by like 60 feet, so it's really small. And if you've seen like a combine harvesting, it's big. So it's pretty, we've really broken those up into really small plots. So I applaud the farm manager for even being able to deal with it, but there's just a limit to how much accurate data we can get when we're harvesting with a combine. So we have to do it by hand.
I was just wondering, like, I'm sure you've done on-site studies too, or plan to, because that's the other thing, is like, I've understood, at least in Texas, they don't trust a lot of research data because it's all these tiny plots, and they don't like that.
Right,
And
sure.
I was just curious, like, what you thought,
So-
or maybe keep these.
And actually, these are large plots. So the cover crop is planted on 180 feet
Right, so
by 30 feet wide, so that's full-scale farm equipment. So this is practical, yeah, but if you do it on real little plots with hand equipment, you say, well, you can do that in your garden.
like the micro plots are that small, but yeah, but I mean, I think, yeah,
So
it's,
these are, when Melissa said they're small for a farm scale combine to try to get a yield on it, because it's not very, 60 feet. 60 feet is, wider than this room by far, twice as wide as this room, so they're not tiny. But the whole strip, so the rye strip and the three-way strip is 180 feet long. That's pretty good.
Yeah, I think there is value doing research on working land though, but at the same time, there is some limits to that because, you know, this is someone's livelihood as well. We also have like nutrient management requirements and all sorts of different restrictions on what you can do. So there's some challenge in getting that. And it's also sometimes just, we can just not really we just want to try a few things and see if it works. And then if it does work, we think, okay, let's try it on a real farm and see what happens. But we wouldn't want to try it just without, I think, getting some advanced data.
All right, well, thanks very much, Melissa.